Good afternoon. My name is Alex Jordan with Ciclu. Time is 4 p.m. Sunday European time, 3 p.m. British time. So we're going to start the presentation today. I hope everyone can hear me okay and everyone can see the screen okay as well. We're going to go through a presentation with you. Take about 40-45 minutes, after which there'll be some time for questions and answers as well, but please feel free to use the dashboard online to ask any questions during the presentation as well. You will all receive a copy of the recording of the presentation afterwards as well, so you will get that, and you can also reach out to the presenters for any further questions after the presentation. So thank you for your time, first of all, today. My name is Alex Jordan. I'm with Ciclu, and the title of the presentation is Solving Your Wireless Congestion Problems is Easy. So we're going to be talking all about solving those wireless congestion problems that I'm sure many of you are familiar with. So again, introducing myself, Alex Jordan. I'm the Director of Business for the Security and Surveillance market with Ciclu. And also with me on the line today is Tim Murphy. Tim is our pre-sales manager, and he's going to be covering some slides, some of the technical aspects. Tim is over about 30 years in the wireless business, so he's definitely a subject matter expert. Tim, are you on the line? Can you hear me?
Yeah, I hear you just fine, Alex.
Thanks, Tim. Okay, so we'll make a start. So what we're going to be looking at today is these topics on the agenda. So first of all, wireless network congestion. What is it? Is it fact or fiction? Then we're going to be introducing millimeter wave wireless, and this is the topic of the conversation today. Applications for this technology, particularly in the security market. We're going to introduce Ciclu, a little bit about Ciclu and our position in the market. About our solution, the type of support services that we offer, and then we'll have a question and answer session at the end. So the first thing I want to actually address and look at, wireless congestion. Is it myth or reality? I'm sure many of you online today have experienced this. So, deploying a wireless network, particularly in an urban area, in a city or a town, or it could be a large complex like a port or an airport, can be fraught with problems. Those problems can be because there's so much wireless activity these days being deployed, particularly said in dense urban areas. So those wireless networks could be being used to transport a multitude of different applications and data wirelessly across the network. It could be video surveillance, security cameras, but it could be Wi-Fi backhaul, or it could be audio, it could be license plate recognition, access control, the host of different types of applications, and really it's a case of it's getting worse rather than better. There's more and more wireless being deployed out there in cities, even vehicles now have a lot of Wi-Fi enablement built into them, and really the question is, do you want to put your critical infrastructure, your high security video surveillance system on a wireless network, a wireless backhaul, which uses the same types of frequencies, same types of technologies, and is fraught with that type of congestion? So I think we can probably all agree wireless congestion is reality today, and in some cases worse than other cases, but it's something which is getting worse and worse rather than better. If anyone disagrees, please feel free to put in a comment now. So in terms of video surveillance, what are the different types of network options that are available, if you like, to provide that type of connectivity between the cameras at the edge of a system, the video surveillance cameras, and the core, if you like, or where you've got your video management system located, your servers, your storage, where the monitoring, the recording, etc. is being done. So as I'm sure many of you know, there are a few different options for that connectivity. Fiber is obviously the number one choice, if you like, and if there's fiber availability in a city, that's great. It's normally the best option, and if it's available already to use, provides multi-gigabit capacity, very high capacity, and also very high level of availability and stability. But the problems with fiber is it's expensive to deploy if it's not already in existence, and also the deployment time. So having to dig up the streets creates a lot of disruption, obviously, and the actual cost to deploy it as well. Then another option, as opposed to fiber, putting in fiber, is using wireless. So what I call legacy wireless, something we're going to look at in a minute, is more the traditional type of wireless technology, which is out there already. It's been out there for many, many years. And it's traditionally using the what we call sub-6 gigahertz frequency, so the low frequencies. Same frequencies used by Wi-Fi, so 5.4, 5.8, 2.4, etc. Benefits of this technology are, well, first of all, low cost. It's also, easy to deploy, quick to deploy. But the drawbacks of this type of wireless are that, first of all, it's limited capacity. So traditionally, it would only really provide you with about 100 megabits per second throughput maximum. So particularly now with the spread of the adoption of HD 4K cameras, which require increasing amounts of bandwidth, you can get issues with bandwidth problems. And the other major problem with this technology, legacy wireless, is the overcrowded spectrum. So again, the problems with congestion, with interference, particularly in dense urban areas. So there is a third way. So the third available option, which we want to introduce to you today, is what's called millimeter wave wireless. So this is a new technology to the security industry. It's not a new technology in the telecommunications industry. It's been around for quite a while, but it's heading to the security industry. And the three key things that this technology provides is, number one, multi-gigabit capacity, so very high levels of bandwidth or throughput. And when I'm talking about high levels, I'm talking about either a gig all the way up to 5 gigabits per second full duplex throughput. So a big pipe, basically, for your multiple HD 4K cameras. Secondly, interference-free, zero interference and zero congestion, and we'll talk about that in a minute, how that is achieved with this type of wireless. And thirdly, typical benefits of using wireless, which is deployment time. So very quick deployment times, quick to install, easy to install, and also low cost. And it's really providing the same type of performance as fiber with all the benefits of wireless. So it's really a combination of both fiber and wireless, which is why we actually call it fiber-like wireless. So this type of technology, millimeter wave wireless, provides fiber-like performance. So Tim, can you tell me a little bit more about millimeter wave wireless and what it is?
Yeah, the area where typically where most security has been is in the sub-6 range. That's, if you look at that, that's actually a very small chunk of bandwidth, and if you actually look at the individual frequencies, they're even smaller. If you look up at millimeter wave, we've got two distinct bands. We've got 60 gigahertz and 70-80 gigahertz. We have tons of real estate there. In V-band alone, and again, it's going to depend on by country, by region, because different countries have different bandwidth size, but it's a minimum typically in the E-band or the 70-80 of 8 non-overlaps, and then in V-band it's again going to vary by country, but we have as many as 11 non-overlaps in the 60 gigahertz. It just simply means you have tons of real estate. Like typically in an 802.11 channel, you're at 20 megs. In the V-band, we've got channel sizes of 125, 250, and 500 megabits. It's megahertz, excuse me. It's much wider, and it's gives you a lot more real estate to work with. Alex?
Okay, thanks, Tim. I appreciate that overview. So why is millimeter wave wireless fiber-like? Why do we describe it as providing fiber-like performance? So the three key things to remember about millimeter wave are, first of all, no interference, secondly, multi-gigabit capacity, and thirdly, low latency. Now, this type of technology is extremely fast. So it's actually as fast, in some cases, even faster than fiber. I don't know if any of you have heard of high-speed trading, for example. The high-speed traders, basically people working on the stock exchange, some of them are actually using this type of technology, millimeter wave wireless, because it's actually faster than fiber. So extremely low latency technology. So if you're doing situational awareness or you're using PTZ cameras, for example, for pencil zoom, this is an ideal technology because you're going to see very, very little latency. So it's extremely responsive. So Tim, tell me, how does millimeter wave wireless deliver multi-gigabit speeds?
The key thing is back to what I was saying before, was it's purely bandwidth, and you've just got tons, literally, we've got more real estate, and because we've got more real estate, we can deliver more throughput. That's what it comes down to. So it's wider channels, higher capacity, as the slide says. If you actually look at the example here, it shows a 5.8, individual channel is only 20 megahertz. Even if you bond those channels together, and by the way, when you bond, you just consumed your entire band, you still are not even approaching the size of the capacity that you have in millimeter wave. The additional thing is that the beam size is so small. It's about the size of a pencil, so it means highly focused, so non-interference, which is the other big part of it, because if you don't have interference, you can use it reliably and you can use it effectively at very, very high data rates with lots of non-overlapping channels. And if we were just using a 500 megahertz channels, for example, we've got, off of 1 point theoretically, I've got 8 non-overlaps, I've got 2 polarities because it is a single polarity technology, and to reuse the channel I only have to be off by 90 degrees. So if you just, theoretically speaking, off of a single point, if you do 2 times 4 times 8, I can do 64 points off of a single site, and that's something that can't be replicated at all in the lower frequencies. Alex?
Okay, thanks, Tim. So many of you may have heard the expression Fresnel zones before. This is the beam angle, if you like, between 2 radios. Tim, can you explain what the Fresnel zones are and how Fresnel zones in millimeter wave differ from a traditional sub-6 gigahertz type link?
Yeah, Fresnel zone is like an elongated rugby ball. So you look at it, and it literally, it's at what's called a first Fresnel, and it's a zone, even though you can see the other side, you can't necessarily make the connection because something's impeding into the Fresnel zone. Like in this example here, traffic, if you have it at street level, cars can actually cause your signal to actually either performance be reduced or drop completely because you have vehicles intermittently on a street level deployment actually affecting the Fresnel zone. The size of the Fresnel zone is roughly about less than a third if you compare 5.8 to 60 gigahertz. So a 60 gigahertz Fresnel is about 1/3 the size. So even though you can see the other side in many other technologies, you can't get to the other side because you have objects coming into that Fresnel zone. To sort of boil it down to a quick phrase, it is, if you can, with millimeter wave, you can see the other side, you can shoot the other side. Alex?
Okay, cool. So in this example, Tim, what you're saying, over a 1 kilometer distance with a 60 gigahertz link in the millimeter wave spectrum, the Fresnel zone's only 1 meter radius, whereas with a 5.x wireless link, it has a radius of 4 meters over the same distance. Is that correct?
Absolutely.
Okay, cool. Excellent. Thanks, Tim. So what about security? So obviously security is a pretty big thing nowadays in terms of network security, cyber security. What kind of security features are part of millimeter wave, if you like, to ensure that the data cannot be hacked and it's actually secure? Well, can you tell me a little bit about that?
Absolutely. Where millimeter wave was originally produced was to actually do inter-satellite communications. The idea was actually developed with security in mind. In fact, many would advocate that it's going to be way more secure than standard copper, and some would argue it's even more secure than fiber, and here's why. Before we even talk about AES, which we do have both AES 128 and 256, the beam itself is only the size of a pencil, as I said. That means you have to be directly in the beam path or behind the beam path even to start looking at the signal. But on top of that is that every radio is proprietary. That means we're using so our radios can't listen to Huawei's radios, can't listen to NEC's radios. We can only listen to our own radios. In fact, even within certain types of radios, can't communicate between other radios. That's important. So even if you have, and so even if you're in the direct beam path and you have the exact same radio, you still have to fully synchronize the transmission. If you don't, what happens is that you can't even talk to the radio. So and this is even before you talk about AES. So in terms of security, many would argue that millimeter wave is the most secure medium of data transmission. Alex?
Okay, thanks, Tim. Appreciate that. So basically, wireless fiber or millimeter wave fiber, if you like, provides quite a lot of different benefits from a security network type application. So we talked a little bit already about the amount of spectrum that we have available. So we have 20 times the spectrum available compared to a traditional, 5.x type wireless network. We have significantly more capacity, so at least 10 times the capacity, depending on the amount of capacity required, gig, 2 gig, all the way up to 5 gigabits per second. So we can deliver a lot of cameras, basically 8 cameras from one location to another. In terms of reliability, very reliable because we operate at a higher frequency, so we're not subject to interference or congestion. The footprint, now that's an interesting one. Tim, tell me a little bit about the footprint. What's the actual size of the radio compared to traditional type wireless?
Yeah, in our 1 foot, our standard E-band radios, it's literally a 1 foot dish, but we do have antennas going all the way down to or 31 centimeters, and we have units going all the way down to 6 by 6 inches, which is, help me Alex here with centimeters here, which is about 12 centimeters. 12 centimeters.
Yes.
12 centimeters. And so it's very small, and really when you put it up and you mount it, the radio literally disappears onto the street furniture. It is just a outstanding deployment, and many people don't even recognize it as a radio. It actually looks like a small little electrical box. Alex?
Okay, cool. Great. Now, thanks for that, Tim. Appreciate it. So, what about weather? What kind of effects does weather have on this type of technology, Tim? Can you talk a little bit about that?
Yeah, the key things that affect it is, and the effect is actually very demonstrable, is just raindrops. But we're not talking about we're not talking about just tiny little raindrops. It's raindrops over 7 millimeters. That's what can have an effect on it, but that's only at distance. And the way we adapt to that is with adaptive coding and modulation, or ACM. It allows us to keep the signal up at the maximum amount of throughput even during inclement weather. So the network stays stable, stays reliable, especially if you're having different types of data flowing through the network. You can keep the core essential data always coming through that you truly have to have, while giving you more than enough bandwidth for the rest of your data coming through your network, even during inclement rainstorms. Alex?
Okay, thanks, Tim. We actually had a question come through on the question bar. The question is, what's the maximum distance between radios? Tim, do you want to answer that one?
It's going to depend on which band you're using. If you're talking about 60 gigahertz, and remember there's 2 sections of the 60 gigahertz that you can use. There's the lower bands. They have a thing that's limited to a thing called oxygen absorption, because 60 gigahertz excites oxygen molecules, and that will limit the distance to about 750 meters. But once you get outside of the range, it's very tight. So there's another upper 3 channels, and at that point you can run, it's essentially equivalent to what you can do in the higher 70 and 80 gigahertz channels. So you can now use up to almost 2 and 3 miles. In the E-band or the 70, 80 gigahertz, we have radios that can easily go into the 5-kilometer range. So that's kind of what the distance is, and you use the antenna size and the radio. It determines the amount of distance that you're going to get for a given frequency. Alex?
Okay. What kind of, the same person asked the same question, what kind of throughput would you get at those kind of distances? So 60 gigahertz, for example, at a range of about a kilometer, what kind of distance are you going to get within the 64 to 66 gigahertz frequencies? Are you going to get full gigabit throughput roughly?
That's a beauty of millimeter wave. Whether you're talking about a 100-meter link or a 1,000-meter link, it's the same throughput. In other words, you get a gig at 100 meters, you get a gig at 1,000 meters. That's the beauty of millimeter wave is it's a very consistent signal. The thing that really varies is availability. Okay, the farther you go out, the more potential you have to have some effect through that weather could have. But it's very calculable, and we know how to work with it. It's very predictable. Alex?
Right. So you can actually design a system to give you full throughput, either a gig or 2 gig or even 5 gig with 99.999% availability, even when it's raining very heavily.
Absolutely.
Great. Okay. Thank you. And what about other types of weather, Tim, like, for example, snow or anything like that? Do they affect millimeter wave?
That's the beautiful thing about millimeter wave is it's not affected by dust, snow, fog, stuff that normally will drive some other mediums just totally crazy. As this slide shows here, is that it's multipath doesn't affect it, interference doesn't affect it, beam spreading, all these things that typically affect other bands have no effect on millimeter wave. Really, it just comes down to working with weather, and we've got great systems with adaptive coding modulation that'll actually adapt to that, and it's very predictable, and so we can actually give you, true availability, and it's something that we have a modeling tool that we'll talk about in a little bit that'll actually show you exactly the kind of performance that you can expect out of the link. Alex?
Okay, thanks, Tim. I appreciate that. So can you give me maybe an example of a weather event where V-band, so 60 gigahertz, is being used, and the type of throughput availability that was achieved?
Yeah, this was done by one of our wireless ISPs in San Francisco. It's at a 740-meter link. Keep in mind, maximum distance is 750 meters. 740 meters, and this was during a 100-year storm, a storm that they called in San Francisco Stormageddon. And this is the real results off of this is a 60 gigahertz link, and this is at the height of the storm. And typically, even our link budget calculating tool showed that it should have because it's very conservative, showed that the link should have been up, but not quite as amazing performance as it did. But in the real application, the link outperformed what our tool said, and it's literally the link stayed up. And this was during a 100-year rainstorm, massive rain, and the link stayed absolutely stable. Alex?
So they were basically getting virtually 500 megabits per second upload and download, then even during the...
Yes, as it was showing here, it was 437, 426, very close to absolutely maximum throughput, even during a 100-year storm. Absolutely.
Okay, cool. Thanks, Tim. Actually, we just had another question come in. Again, actually, you know what? I don't think I've been asked this question before. But what about sandstorms? So, the sandstorms. So, I guess sand in the atmosphere, the air affects a millimeter wave. Any experience with that?
No, sandstorms won't affect it. Dust doesn't affect it. Again, think of it in terms, it's objects bigger than 7 millimeters, and it has to be of a high density, like in a rainstorm. So snow doesn't affect it. It has to. So the only thing really affects it is raindrops over 7 millimeters. Alex?
Okay, cool. Thank you, Tim. So taking a look at the different applications where this type of technology can be used now. So in terms of the security market, and bear in mind, particularly we're not just active in the security market, we're also active in many other markets, and particularly the telecommunications market, working with internet service providers, which Tim mentioned a little while ago. But in terms of security markets specifically, what are the different types of applications where this technology can be used? So there are a range of different applications, really anything where you're trying to connect a camera back to an NVR, back to a place where you're doing the monitoring and the recording, and you don't have a hardwired connection. So you don't have fiber, you don't have copper, and trying to deploy a hardwired network connection can either be very costly or simply impossible, or maybe a bad return on investment. So this is kind of a list of some of the different applications where this technology can be used for. So airport ports is a very good application, particularly because we operate in a high frequency, so we don't interfere with types of wireless that you may find at an airport and port, for example, communications. Public safety is a very, very large one, particularly in urban areas, so city surveillance, for example, monitoring city centers as a good example. Campuses, so universities or hospitals, utilities, railway lines, parks. There's a host of different applications. We've actually got some that we want to share with you where this type of technology is being deployed. Now, one thing to remember, and we kind of talked about it a little bit earlier on as well, often in these types of applications, millimeter wave wireless is not the only type of network communication used. Often it's a hybrid, if you like, of both fiber and wireless. So often in a city, for example, there may be fiber located around the city or linking perhaps certain city buildings together, but you may not have fiber everywhere to every single location, every single point where you want to have a camera. So in those applications, putting in a wireless link, a millimeter wave wireless link, is a good solution because it's still going to give you the same type of performance as you get out of the fiber without the cost and the disruption of putting in additional fiber. So that's what we call a hybrid fiber wireless type system. So in terms of where Siklu has been deployed, this is an example just in North America. So we've actually deployed a number of cities across Europe as well, particularly in the UK. But in the US in particular, we've got over 33 cities deployed already with this type of solution, and this is for security video surveillance. And we have a number of additional cities, actually more than 11 cities now in planning stages as well. So for over the next few months, we'll probably have in the region of about 45 to 50 actual cities deployed with this type of technology. And this has really been only in the last 18 months or so. So it's a technology which is being rapidly adopted and rapidly deployed, not only across North America, but also in different parts of the world as well, including in Europe. So one particular application that we want to share with you, because it's a very interesting one, where Siklu was used is in the town of Fort Myers in Florida. Now, Tim, I know you were heavily involved with this from a design perspective. Do you want to talk a little bit about the challenges with this particular project?
Yeah, this is how you consume my bank holidays. But let me first off, there was a couple of questions here that we had. First off, is it asymmetrical or symmetrical solution for millimeter wave? In the TDD units, which is what are 60 gigahertz radios, and we do have some of the 7080, we do both symmetrical and asymmetrical operation. Any half duplex radio we can absolutely do that in. So it has the ability to run, either 50-50 symmetrical or 75-25 asymmetrical. And it is, Alicia, it is only point-to-point, okay, at least today. There are some things in the future we're working on that will be interesting, but that's for another discussion. And then Klaus just said hello. I'm not sure what he's asking because he asked about the sandstorm. But Klaus, if you want to ask your next question, I would be glad to answer it. But back to Fort Myers, this one was very, very high throughput. Alex, what was the bandwidth of each one of these poles again that we had?
The bandwidth was about 70 megabits per second coming off each pole, and that's because they had three cameras mounted onto each lamppost, and they had about 17 of these around the city center. These are axis cameras, so they had a couple of multi-sensor 33 megapixel cameras giving situational awareness, 180-degree coverage, plus a 1080p PTZ camera for pan-tilt zoom. So the combined throughput was 70 megabits per second.
Yeah, Klaus also has the audio dropped. You may want to dial into the phone call section because that'll get your audio back. So, but back to the Fort Myers is that what we did is, because of the high demand of each one of those poles, is that we actually created 3 rings within the network. we actually, it was on a very rapid deployment schedule. We actually designed it in less than 4 days, and the network was literally, they asked us the end of November to design it, and it was deployed before New Year's Eve. It went really fast, and the system worked. It was this one where they were trying to, they actually had a situation that occurred called ZombieCon, where they actually had a shooting, and they were very concerned about their New Year's Eve celebration that they were going to, because again, this is a tourist town, and they were very concerned about securing that public area. And they were on an incredibly short timeline, and it worked amazingly well. Alex?
Okay, thank you, Tim. So just to kind of point that out, so they actually deployed a mesh network in this town, is that right, using Ciclu? Can you do that with point-to-point wireless?
Well, yeah, absolutely. What we did is we did 3 separate rings, and we actually used a thing called ERPS, which is Ethernet Ring Protect. It's a typical wired standard that we have available in our radios, and we did 3 rings. So literally, if one of those links goes down, it can actually fail over and create a back up the ring, and that failover happens in 50 milliseconds, very fast. So it actually acts as if it was a mesh, if you will, but it's actually doing it's more like a commercial grade, because this is really telco grade equipment, but it's more like a commercial grade network mesh, if you will, but it's using Ethernet Ring Protect as redundancy. Alex?
Great, thank you. Thank you, Tim. I appreciate that. So we've also got some examples of actual applications in Europe. So, for example, recently we did a deployment in the city of Bradford in the UK, and this was a deployment together with cameras from Axis, Hikvision, and also Bosch. And here they used a number of different Ciclu radios, including both the V-band 60 gigahertz for street level deployment, so actually connecting to the cameras at street level on lampposts and traffic signals, for example, as well as using 70 and 80 gigahertz E-band for longer range, 1, 2, 3 kilometer backhauling, if you like, from rooftop to rooftop, so aggregation points. So they had over 300 surveillance cameras connected in this networking, and also some variable messaging signs that they're actually carrying across the same wireless network. This is also a hybrid fiber as well as a wireless network that was actually used in this particular type of application. So another one that was done in the UK was in Oakham Council, and we actually used 60 gigahertz radios here, and these are actually lower bandwidth. These were just 100 megabit per second radios because they didn't really need the throughput capability, but what they didn't require was the no interference, zero congestion, zero interference capability of these bands. And that's why they selected the Ciclu 60 gigahertz radio, just with a lower throughput capability, 100 megabits per second. They're actually using, again, Axis cameras connected to a milestone video management system, again, because of the lack of interference and congestion. Tim, would you like to talk a little bit about this project which you were involved with in the town of Vail in Colorado?
Yeah, Vail was an interesting challenge because they couldn't use fiber because the streets are heated, so therefore they gave us an estimate that it was like $10,000 a square foot to run fiber in the ground. So the problem is they had an existing Wi-Fi system. They were trying to run both cameras and a public Wi-Fi network off of the same system, and it wasn't working. It was poor performance Wi-Fi, very poor performance and inconsistent for the cameras. So what we did is we did all their backhauling on our 60 gigahertz radios. The network became very, very fast. The camera performance was absolutely flawless. And then we redeployed the existing Wi-Fi network using both 2.4 and 5.8 for client access. So therefore, you can walk around Vail, Colorado, and cruise the internet on your phone at about 125 Mbps. You see a lot of happy people in Vail, Colorado. Alex?
So another question just came in, Tim, to do with this as well. So can these Siklu radios, I think they're specifically talking about the V-band 60 gigahertz, be mounted onto lampposts, like in this application? Are they designed for that type of application? Are the beam angles not too tight for mounting onto lampposts, where you may get a little bit of sway or motion?
That's a great question, Alex. But the 60 gigahertz units are actually designed to be mounted onto lampposts or signal lights or street furniture, if you will. And it actually has 1.25 degrees of what's called torsional force or twisting force. By doing that and doing that design, it's superb for what we call below the treetops applications. So it's exactly what it's designed for. On the other hand, on the 1 foot and the 2 foot dishes that we have for our 70 and 80 gigahertz radios, you want to have those on very stable platforms, because the 2 foot dish is about a quarter of a degree of torsional force. The 1 foot dish has about a half degree of torsional force. But so it's two different applications for two different types of radios. Alex?
Okay, thanks, Tim, for answering that one. Okay, so this is another application where Siklu radios were used. This is in the town of, or city of Venice Beach in California in the U.S. And this is an interesting application because this one was actually brought about due to a murder which took place in 2015. There was an Austrian tourist who was murdered, and the city actually decided they really had to put in a video surveillance system. They had no video surveillance at all of the Venice Beach boardwalk with a lot of tourists and a lot of activity. So they decided to put a video surveillance in place. They had no fiber going down that street, and the street's several kilometers in length. So putting in fiber was just going to be too cost prohibitive, which is why they chose a millimeter wave wireless type system, again, which wouldn't have any issues with interference or congestion. And they deployed a Siklu system together with Samsung hand-lock cameras. Tim, this is another type of application. This is a non-city one, if you like. This is actually a port application, the port of Long Beach in California. I know you are quite heavily involved in the design of this project as well. Do you want to spend a minute or so talking about this application?
Yeah, this is one of the largest ports in North America. They had several legacies, licensed wireless in both the sub-6 as well as the standard license spectrum, and they replaced that with an entire Siklu network. The idea here was they were more concerned about interference-free, very high capacity, which was another one of their goals. It was about a deployment that took about 4 or 5 months. Lots of planning went into it, and these guys are just so pleased with the performance because now they have an absolutely stable network with zero interference and with throughput that far exceeds even on their license spectrum that they were achieving. And everybody from the port through the integrator were incredibly impressed. In fact, expectations were exceeded with this network. Alex?
Okay, thank you, Tim. Appreciate it. Okay, and this is another example where millimeter wave wireless can be used. Again, a different type of application, but commercial perimeter protection. So this is a customer, is actually a global car auctioneer. So they actually sell tens of thousands of vehicles globally. Basically, it's an auction house, so they have huge sites where they're selling cars, basically. And again, these sites don't have fiber. They have a lot of acreage to cover, so they're using millimeter wave wireless from Siklu to actually connect their cameras together. In this case, it's in a Vigilon system. In this particular example, they didn't even have power at the locations either, so they actually used solar to power both the cameras and the wireless, which was a nice application as well. So just one thing to say about fiber, really. So we talked about how Siklu is really an alternative to fiber, where fiber is expensive, but we like to say that we're really an extension to fiber. So we're not necessarily an alternative to, but sometimes fiber isn't available, and to deploy it's just going to be too expensive or not a good return on investment, or it's going to be too disruptive or take too long. In those instances, wireless, millimeter wave wireless is a great technology to use, really extending the reach of the existing fiber. So those parts where fiber doesn't reach, if you like, think of putting in millimeter wave wireless, because it really is giving the same type of technology benefits. So we talked quite a bit about, obviously, Siklu on this call. Tim and I both work for Siklu. So a little bit about Siklu as a company, where we come from, etc., how large are we. So Siklu, we're actually the number one global millimeter wave wireless company. So we've actually deployed more millimeter wave wireless links than any other company globally. We've actually got over 40,000 links deployed in over 30 countries. So the technology is very, very stable, very, very widely used. We've got a calculated mean time between failure of greater than 90 years, which basically means that the products are extremely reliable. And we've got over 50% market share globally, so we're definitely recognized as the leaders in this technology. We're definitely making very major leaps, if you like, in the security industry as well. So the company was founded in 2008, so we've been around for about 8 years, but obviously growing very rapidly. We're headquartered in Tel Aviv in Israel, but we do have offices in the US, UK, and Russia as well, including professional services and technical support in all those countries. And we've actually got over 35 patents filed, so the technology is very, very strong, and we actually own the technology as well. So in terms of our product offerings, I'm not going to go into products in a lot of detail, but we're basically providing millimeter wave from the edge, so from the camera, if you like, all the way up to the core, so the actual backhaul, if you like, to the VMS or the NVR, the network video recorder. So we're doing both the short distances, using the 60 gigahertz up to about 1.2 kilometers, all the way up to about 6.1 kilometers, if you like, using the 70-80 gigahertz, and this is based on deployment in London, by the way, with 99.999% availability, so very high level of availability in a high rainfall area, high rain zone area.
So Alex, I'd like to also add to that slide just one quick second, is that we did have a question come in about what's the maximum throughput at street level. We do have a device that we do have in Europe that we don't have in North America. It's called the 710. It's a 70 gigahertz radio that is a street level, so it's that smaller form factor, and that can go all the way up to 1.4 kilometers with a 99.9% reliability, which is amazing for street level performance, and at shorter distances even a higher availability. Alex, back to you.
Great, thank you, Tim. So the other feature that we actually have built into the radios, and this is a really nice feature, particularly in the V-band or 60 gigahertz radios, which are at the edge on lampposts, if you like, is that they have dual PoE out. So Tim, can you talk a little bit about how this can be used and how it can be used to simplify deployment with cameras at the edge?
Yeah, it means it's a one-wire install. You can power the units. We have PoE injectors up to 90 watts. So literally on the top example, you can have one PoE in powering that radio and powering another radio. Now keep in mind you still have 3 free ports, and you can actually power 2 or 3 devices. Again, you just have to keep track of, you've got 90 watts to work with. The radio consumes 26 watts. A second radio would consume another 26 watts. But that still leaves you 54. That still leaves you 36 watts of devices that you can run off that 90 watt PoE. In the other example, off of one PoE in, I can run 2 devices. I can run them in different configurations. I can run an AF and up to an AT+. So a very high power with some of the new PTZs that are available, or I can run 2 ATs at the same time off the same device. Again, it's just a matter of working out the calculations of the total draw of the radio, which is only 26 watts, and then calculating out what the draw is the other devices. But with the 2 PoEs often means that you don't need a separate power source and you don't need to put in a separate switch. Alex?
Okay, cool. Thank you, Tim. So, Tim, Tim, you're part of the professional services team, and I know there's a number of you based around the world providing 24/7 support for our customers. What are some of the services that you provide as part of your team, as part of pre as well as a post sales type support?
Well, obviously we provide technical support, and really we are a follow the sun strategy. So our goal is to always respond back as quickly as possible. One of our highest compliments is when we respond back to somebody and say, oh, I just typed you that question, or I just called you, and we respond directly back. But we provide training, we provide troubleshooting. Remember, troubleshooting doesn't stop after your warranty expires. We want to make sure that even after the warranty, we're not going to charge you for technical questions. We don't charge you for software upgrades. We don't charge you for wireless planning. We'll actually help you design and plan your network. And especially the more complex things, like if you're trying to do like Ethernet ring protect, as we talked about earlier, we'll actually go, because it is a more advanced type of programming of the radio, we'll actually do that and create those scripts for you, and we'll do it as a service to you because we want to see you deploy the network. So we do post-sale support. We do have our partner portal, which is a self-service, so you can actually do a lot of your own, get your marketing questions answered, as well as a lot of your general technical questions are answered, as well as software is there as well. And then we can do things like extended warranties. We can do higher levels of service agreements. So there's a lot of options we can do, but the bottom line is we want to be not just your best microwave vendor, but we want to be the very best vendor of any vendor that you deal with. Alex?
So in this drawing on this particular slide here, I know this is a particular city in the U.S., but is this the type of design you do? So using Google Earth, creating a KMZ file, showing the different wireless links, for example?
Exactly. What we'll do is we'll use Google Earth and work with the client, and we'll go through and we'll use Google Earth. We'll also use our internal tools to various levels. And we'll actually help you plan out, so you actually will have a full KMZ of the site, of all the links on the site, and then we'll go through and create a site list, so you actually have some true documentation of what the site is going to look like before you actually go to deploy it. Alex?
Okay, I just had another question come in actually. Do you require line of sight for your wireless links?
Absolutely. Millimeter wave is definitely a line of sight technology. The nice thing is, though, as we talked about earlier, it has an incredibly small Fresnel zone. So that means if you can see the other side, you can shoot it. It means that you don't have to go do RF studies. You don't have to go do frequency analysis. Literally, a site survey for millimeter wave is standing on from one side to the other. You can see it, you can shoot it. And that's all you really need to do. The issue with lower band, you have to worry about, all the interference issues. You have to worry about all those other issues that are part of lower frequencies that simply don't exist in millimeter wave. Alex?
So were you saying a millimeter wave, you don't have to do any kind of spectral analysis as part of the design to see what other types of wireless frequencies are out there being used?
Typically, absolutely not. Only in the most extreme cases. There's a building in North America in Los Angeles called One Wilshire that has literally over 150 radio antennas, 30 of which are just Ciclu 780 gigahertz. That building you may want to do a little bit of a spectral scan, because that's an extreme example, but 99% of the cases it's absolutely not necessary.
Okay, cool. Thanks, Tim. Okay, so this example here where we're providing link path calculations, is this the type of service you also provide as part of your team?
Yes, this is actually in a typical deployment. We'll go through, this would be associated with a KMZ file to actually show the physical paths that we're working with, and then this is just a document that will show you the amount of availability, the throughput, the distance of each link, and show you the amount of performance. And this particular one is that all these links we're going to achieve 5 nines worth of throughput. And it's millimeter wave is one of the big differences between sub-6. Sub-6 is best effort. They can't say that you're going to get 99.99 because they don't know the interference. Ours, we don't have the issue of interference. The factors that affect millimeter wave, and really only one, and that is rainfall, and that's only over distance, is we can actually say with confidence that this link will achieve 5 nines, which is 99.999 or better. And we can design to that standard. And the other frequencies, the sub-6 frequencies, can't do that. You can do that, achieve that with some license frequencies, but now you're talking about the conventional license frequencies, but now you're talking about incredibly high costs. Back to you, Alex.
Okay. Thanks, Tim. Another question came through, which is good timing. And the question is there a radio planning tool for the partners to use? And I think this is the next slide, which actually talks about our link budget calculator.
Yeah, perfect lead-in. Yeah, this is the actual tool that we use to actually calculate the path to link. And really the big thing we're looking at there is we want to look at the rain zone that the link is in. So we actually are using 50 years of rain data here. And then we actually put in the type of radio that's being used with the size of antenna. And then we do have some optional factors like user spare, and you put in the link length, and it actually it shows you statistically what the performance of that link is going to do. And we have a very high confidence in this, that we can say that the link is going to perform like this. And the key thing to look at is the expected RSSI up top there on the top right-hand part of the slide. That number is what you actually align the link to. Is that number there? It's really key how that goes, and that's one of the. So it gives you, not only tells you link performance, but gives you the target number that you align the link to. Alex?
All right, thanks. And by the way, this link budget calculator is on our website. It's actually the link is on there. So if you go to our website, ciclu.com, you'll actually find it on there. So really, as a summary of the things we talked about today, hopefully you can all see this now, that millimeter wave wireless really does solve your wireless congestion problems, because it provides that fiber-like performance with wireless flexibility. So it gives you flexibility of wireless and the performance of fiber. Gives you multi-gigabit capacity, zero interference, quick deployment, and it has been successfully deployed in over 40,000 units or links globally. So now we're going to open up to any other questions from anyone. I got a few other questions that came in. How to buy Ciclu? Where is it available? This is a country-by-country thing. So we sell through the distribution channel. So if you're interested in being able to purchase Ciclu products, if you contact Ciclu, you can contact myself or Tim, or if you go through the website and tell us which region you're looking or interested in deploying Ciclu link. We'll then introduce you to a local distributor who can work with you. We will work with you though in terms of putting the design together. So we do work with you closely on that side. And also on the training side as well, we work with our partners in providing them with training. We also want to make sure that they're very familiar with how to deploy Ciclu. And by the way, we also have videos available on YouTube. So if you go to YouTube and just type in Ciclu, you'll see a number of different installation videos on there as well, which actually shows the ease of install. So they're also very, very useful. A couple of the questions came in. Reflections. So Tim, maybe you can address this one. Any issues with reflections, either over water or from buildings, shooting between buildings?
Repeat that, Alex. You kind of broke up there for a second.
Sorry. Any issues with reflections when you're shooting, for example, over water, like a waterway, a river, lake, or between buildings?
Not at all. In fact, this is the perfect medium for doing that, because multipath is a non-issue for millimeter wave, and shooting over water, because it's such a small wave, it literally, any deformities within the surface, it actually picks up, and you just don't get the reflective issues that you do with lower frequencies. So it is the absolute perfect medium for going over water and shooting in downtown canyons. Alex?
Okay, cool. Thanks, Tim. Network design. Do we charge for network design? It's another question, or do we do it free of charge?
Yeah, like I said before, no, we don't charge network design, and this is something we want to see deploy our gear, so we actively work with you in helping you develop those networks, whether it is just a simple design or highly complex. That we're there to work with you, and we don't charge for that service. Alex?
Okay, cool. Thanks, Tim. Another question, millimeter wave versus air fiber. So I think they're probably referring to ubiquity air fiber, which is a 24 gigahertz.
24 gigahertz. The big thing there is with air fiber, it's literally, it consumes the whole channel. So it's roughly the same throughput, but it's one and you're done. In other words, we've got 2 polarities to work with. We've got 8 non-overlaps, and I can go 4 directions. With air fiber, I think you can use it repeated only 3 directions, so where you can put 3 air fibers on a site, you could, theoretically speaking, you can put 64 cycloos on that same site. So compared to air fiber it's smaller in terms of physical footprint, but also the amount of devices you can get on a single site is better, and also the reliability on our units. If you look at our mean time to failure, we're much higher than what air fiber is. Alex?
Yeah, good. I think also particularly you mentioned about size, but I think